Now we have selected position and thickness of our slice. But how can we find out from what point of our slice a certain signal is coming from? Information that we must have to construct an image. The trick is similar to the slice selecting gradient, which is turned on only during application of the RF pulse. Here are 9 protons in the slice selected. After the RF pulse is sent in, all of them precess with the same frequency. We now apply another gradient field, which in our example decreases from left to right. So, the precession frequency of the protons will also decrease from left to right. In our example, the precession frequencies are 65, 64, and 63 MHz respectively. The result is that the protons in the different columns emit their signals with these different frequencies. The gradient applied is thus also called the frequency encoding gradient. However, all protons in one column will still have signals with the same frequency. We can now tell from which column a signal comes from, but still cannot pinpoint the exact place of origin. As this is not enough spatial information, we have to do something else. Let us have a look at the protons of one column. The 65 MHz column, for example. The protons are in phase after the RF pulse whipping. Now we apply a magnetic gradient along this column for a short time. This causes the protons to speed up their precession according to the strength of the magnetic field to which they are being exposed. In our example, the proton at the top thus precesses faster than the one in the middle, which in turn precesses faster than the proton at the bottom. When this short gradient is switched off, all the protons of the column experience the same magnetic field again, and thus have the same precession frequency. However, there is an important difference. Formerly, the protons and their signals were in phase. Now, the protons and their signals still have the same frequency, but they are out of phase. As the gradient which we used causes protons to precess in different phases, it's called the phase encoding gradient. What finally comes out, after we've applied all these gradients, is a mixture of different signals. These have different frequencies, and signals with the same frequency have different phases, all according to their location. By means of a computer and a mathematical process called Fourier transformation, it can be analyzed how much signal of a specific frequency and phase is coming out. As these signals can be assigned to a certain location in the slice, we can now reconstruct our image.